All right, everyone, we're going to get started with our webinar. Thanks a lot for joining this afternoon. Today we'll be hearing a presentation called Making Bicycling Comfortable, Identifying Minimum Infrastructure Needs Using a Video Survey. My name is Mike Centetos. I'm the Policy Director for the National Center for Sustainable Transportation. I'll be moderating the webinar. This is part of a monthly series that we put on here at NCST. We're part of the University Transportation Centers program administered by the U.S. Department of Transportation. NCST is a consortium of 6 universities around the country focused on advancing environmentally sustainable transportation through cutting-edge research, direct policy engagement, and education of our future leaders. We've got a mailing list where we send out notifications about upcoming webinars and current research. Certainly would encourage you to subscribe at ncst.ucdavis.edu. Today's webinar will last about an hour. We'll have a presentation from Dr. Dillon Fitch, and then we're going to open it up to questions and answers. You'll see in the Zoom webinar platform on the bottom toolbar, there's a Q&A function, so we ask that you use that instead of the chat feature. It's a little bit easier for us to keep track of the questions. We will be recording this webinar. It'll be available with closed captioning on our website along with the slides in the next day or two. And with that, I'd like to introduce our speaker today. Dr. Dillon Fitch is the co-director of the BicyclingPlus Research Collaborative here at the University of California, Davis. So Dillon, over to you.
Thanks, Mike. So before I get started on this project, I wanted to kind of give a background on the kind of the history of why we started this project. So about 2 years ago, I was realizing that we did this video experiment to understand bicycling comfort in Davis, and at the same time, a group of researchers led by Julia Griswold at UC Berkeley were doing very similar work, and they were doing it with videos from UC Berkeley or in and around the San Francisco Bay Area. So this project kind of came about as bringing the two projects together, and you'll see that we're using videos that Julia recorded in San Francisco Bay, but we're using population in Davis, which is kind of a unique population to understand bicycling comfort. So that's where we began, and then so I guess I should introduce my co-authors, Jane Carlin, who is now with the Los Angeles Times, formerly with UC Davis with the Data Lab, and then Professor Susan Handy as well, all collaborated on this project. So here we go, just some motivation for the project. We don't need to spend a lot of time here, but it's clear that cities across the state, as well as in Caltrans Strategic Master Plan, that there's a need to increase bicycling, and there are specific goals about increasing bicycling across California. And one of the major barriers for this, for increasing bicycling, is of course safety, both objective and perceived measures of safety. Most cities use road infrastructure changes as the common way to kind of invest in making bicycling safe. And it's clear from past decades of research that protected bike lanes and off-street paths are basically the most important thing to make bicycling comfortable. However, when you can't put protected lanes and off-street paths, on-road bicycle facilities are still going to be important for providing infrastructure for bicycling. And so the focus of this research is on those on-road facilities, bike lanes, buffered bike lanes, and various other road design features like lane widths and speeds. So this leads to a bunch of broad research questions, and we're not going to be able to answer all of these, but it kind of will help focus why we're doing this research. So the first question, how can we design roads that feel safe and comfortable without physical protection from traffic? A very open-ended question. Is it even possible? And then we know that from various studies that different subpopulations differ in their perceptions of safety. So specifically, women and men differ a lot in what they perceive as comfortable or safe for bicycling. So that leads to the question, do we need to design roads that satisfy different needs based on these subpopulations? And then these questions also relate to very planning-focused question that we often hear about, and that is, when cities go to make investments, should they be providing a lot of cheaper infrastructure, or should they provide fewer but high quality facilities. And although we're not going to answer all these questions, we hope that some of this research at least moves us forward and gets us closer to answering these questions. So the specific research questions within this study, they're a little more targeted. So we want to understand how influential road characteristics are in explaining bicycling comfort. And we want to know which characteristics have stronger relationships with perceived bicycling comfort. And I guess I should take a step back and say that we're using this term bicycling comfort, and I'll show you exactly what the participants saw so that you know what we're measuring. But in the bicycling literature, comfort and perceived safety often get kind of conflated, and that's because there's not as clear of a distinction like there is in the vehicle research realm, where safety and comfort can be very different. So we're using the term comfort because we think it's important to understand kind of the initial barrier to adopting bicycling. So not only do we care about the road characteristics, but we want to know if some subpopulations differ in their view about those characteristics. So we'll look a little bit into that. And then this also leads to this idea of providing infrastructure minimums for comfortable bicycling. And that's kind of like a design standard. If people aren't comfortable riding in bike lanes that are 4 feet wide, but they are in 6 foot wide bike lanes, that becomes a better assessment of a starting point for providing a bike lane. That's the idea. So in this study, we used a web survey as an add-on to the annual campus travel survey at UC Davis, which we administer for the transportation and parking services at UC Davis every year. And the sample size was a little over 3,000 participants, and these are campus travelers, so students, faculty, and staff. And then within this survey, we administered a video experiment. And in that video experiment, we received a total of nearly 15,000 responses. And I'll show you in just a second what the responses looked like. Within the experiment, there were 25 videos, and which were just 10-second clips. And they were organized into 5 classes, and these are pretty rough, loosely defined classes. There were shared arterial roads, shared collector roads, roads that had bike lanes adjacent to fast traffic or rural highways, and then bike lanes adjacent to moderate speed traffic, and then 5 videos that had buffered bike lanes. There's one video that has a couple safe hit posts, but we don't think anyone would really consider that a protected bike lane, so we're still calling it a buffered bike lane. And all of these roads, they were videoed from the San Francisco Bay Area by that prior study that I mentioned at the beginning, led by Julia Griswold at UC Berkeley. And so what's interesting about this study is that we have a population of campus travelers to UC Davis, but the videos all come from the San Francisco Bay Area. So many of the participants are not going to be familiar with these road environments. Okay, and looking at the survey, this is what the participants would see at first. They would come to this screen in the middle of taking the campus travel survey, and they would read, next you will view 5 short video clips, 10 seconds each. For each clip, imagine that you are bicycling in the environment shown, and then rate how comfortable you would feel. And they would advance the screen, and they would get to their first video, and they would push play and watch the 10 seconds and decide how they would rate this video on a 7-point scale, with very uncomfortable on the far left, all the way up to very comfortable on the far right. And they're not allowed to advance the screen until they've either checked a response or checked an additional box that said, I don't want to respond. So this is our response variable, bicycling comfort. Oops, let's go next. So in looking at our sample, we can see that the sample is not representative of Californians in general, and that's not to be expected because this is a specific population that's traveling to UC Davis. Which you might expect, you can see from the top right graph that the age distribution is fairly young, in the young 20s mostly, and that's because if you look in the bottom left graph, The predominant responses are from campus undergraduates. We still have a lot of faculty and grad students and staff that are providing responses to this video experiment as well, but undergrads dominate. If you look at the top left, you can see that we have a lot more responses from women, and that's also pretty common in the campus travel survey, where we tend to get a much higher response rate from women in general. And then on the bottom right, which is the most important, perhaps the most important graphic to describe our population, we have most responses are coming from people who ride a bike to UC Davis. And that's because the bike to campus rate is really high in Davis. And so these are a lot of people who do have biking experience, daily biking experience. That doesn't mean that they're willing to put up with some of the traffic and road environments that we're going to show them on the videos, but it just means that they're perhaps more experienced in reflecting on what is comfortable for them. And that's what makes this kind of a unique population to study for bicycling comfort. So those variables that we just showed are also on the left under what we call the person level. There's also a series of attitude and self-perception variables that we recorded from the survey that we'll talk about a little bit when we get into modeling and some of the other statistics. So we ask about liking bicycling, about feeling safe, or about their bicycling ability. And these things obviously are going to relate to how they rate these videos, the comfort of these videos. But then we have another series of variables that we're primarily interested in, and these are the video level variables. These are the characteristics that were either recorded in the field by Julia Griswold and the team at UC Berkeley, or they were recorded after the videos were taken. They were recorded from watching the videos. And also, in addition to those specific characteristics, on the bottom right, you'll see a few broad characteristics, which are calculations from the highway capacity manual or the NCHRP versions of bicycle level of bicycle level of service, and then follow the very last one, which is the bicycle level of traffic stress, which is another metric for understanding bicycle suitability. So we'll also look a little bit about how those metrics relate to the comfort responses. So in the study design, we started with simple descriptive statistics of the response of comfort, and then we looked at bivariate statistics of how those comfort ratings relate to person and road level variables. And then we ended with the multi-level ordinal logistic regression models, and we built a series of these and compared them, and we'll pick one for doing this planning scenario analysis at the end. So we'll step through kind of each of these levels. So first, we'll look at the video responses. So on the x-axis is the categorical labels for the 7-point scale. So on the left, you have very uncomfortable, and on the right, you have very comfortable. And then on the y-axis are each of the 25 videos. And then what we're doing is you can think of these as smoothed histograms. So these are just representing the distribution of responses for each of the videos. And we've ordered them from top to bottom, from most comfortable, or from most comfortable to least comfortable, or most uncomfortable. And then furthermore, we've color coded them by those rough infrastructure classes, just to give you kind of an idea of what these videos are showing and how people are rating them. So on the top, you'll see that most of those colors are purple and blue. These are buffered bike lane videos, or videos of bike lanes adjacent to moderate speed traffic. And then on the bottom, you'll see that it's predominated by green and red, which are bike lanes adjacent to fast traffic or rural highways, and also shared arterials. And then in the middle, it's a bit of a mix. And it's a bit of a mix because, of course, the infrastructure class doesn't say everything about that environment. And there's lots of kind of subtleties. And that's what we're hoping to show with the models, how the subtle characteristics influence people's comfort rating. So if we take these video ratings and then we vary them by gender, we can see that, not surprisingly, that women in the aggregate always rate every single video as less comfortable than men, and this is pretty consistent with the literature. What's interesting, I guess, about this graphic is that there's pretty much agreement across men and women which videos are worse than others, right? So in the top right, you see that men and women are still in agreement of that Sloat 35 video is the most comfortable. And they're also in agreement that at the very bottom, Grizzly Peak is also the most uncomfortable. So there's this gender effect of rating all the videos as less comfortable than men, but there's no clear differences or varying effect or moderating effect by gender on the different videos. And we'll also explore that a little bit in the model. Another way that we visualize the influence of variables on these comfort ratings is to just aggregate all the video ratings across all environments and then compare across socio-demographics. So rather than using those kind of kernel density estimates of histogram, we just present the total percentage in bars. And so it's a stacked bar from blue to red. Unfortunately, the scale got flipped. So blue is the comfortable side, which is now on the left, and red is the uncomfortable side, which is now on the right. You can see on the top that university roll doesn't seem to have much of a clear effect, at least in bivariate statistics. You can see the big effect of gender, right? So women consistently rate fewer videos as very comfortable and moderately comfortable. In terms of age, there's a slight effect of being younger and rating fewer videos as very comfortable. On the comfort side of the scale, things seem pretty similar, but on the uncomfortable side of the scale, younger participants seem to avoid that. And then finally, on the bottom two, these are survey measures that clearly relate to bicycling comfort. So it's not surprising that there's this strong linear downward trend from top to right. So the first one is bicycling confidence. So you would expect people that are more confident to perhaps rate these videos as comfortable compared to those that are not as confident. And then the same on the bottom is a textual description of, are you comfortable bicycling on a 4-lane road with no bike lane in good weather? And you can see that those that say they're comfortable, they're much more likely to say that these roads are comfortable for bicycling compared to those that are not uncomfortable. When we shift from the person level variables to the road level variables, it gets a little more complicated, and maybe we can't touch on all of these, but I'll just point out a few. If you look at the top right, we've represented the presence of a bike lane with a 1. So we can see that when a bike lane is present, people are much more likely to say that that environment is comfortable or very comfortable. And there's a very large shift from that compared to when the bike lane is not present. For speed on the top left, it seems a little ambiguous, and that's perhaps because there aren't very many different speed limits. And then if you look at prevailing car speed, which is diagonal down to the right, you also see this kind of jumpy pattern. There's no clear linear trend. So a lot of that is going to get figured out in the multivariate modeling. But from bivariate statistics, it's not clear that speed's having much of an effect. But we'll get to that later. Some of the other large effects that we see just to the right of prevailing car speed is number of car lanes, or when there's one lane in the traveling direction of the bicyclist, we see many more people saying that that would be more comfortable. And then in terms of bike lane width, which if you look in the center column in the bottom 2 panes, bike lane width and bike operating space, you can see that when the bike lanes are wide, people are saying they're very comfortable, much more likely to say they're very comfortable. And then bike operating space adds any shoulder and buffer to the bike lane. And again, you can see that more space leads people to say they're more likely to be comfortable. So as I said earlier, we also wanted to compare the video responses to these really common planning metrics for bicycling, the NCHRP and highway capacity manual versions of bicycle level of service, and also the level of traffic stress. On the left plot, what we've done is we've converted the 7-point scale into numeric on the y-axis. So that's where you see the 1 through 7. So 1 meaning very uncomfortable and 7 meaning very comfortable. And then on the x-axis, we've plotted the letter grades for those bikeability metrics. We've converted the level of traffic stress 4321 to C or DCBA to a line. And what you can see from the left graphic is that the average comfort rating clearly is positively correlated with those scores. So that's what we would expect. When those scores say the environment is better suited for bicycling, our participants say that they would feel more comfortable riding there. However, if you look to the right, where we've got the comfort rating now on the x-axis, and we've used the same kind of smooth kernel density estimates of the histogram, we see something really interesting. If you look at the y-axis where it says A for the 3 various colors, that's those are the top rated environments according to those bike suitability metrics. And what you can see is that there's huge spread in comfort ratings across those best environments. So that means that when the bicycle level of service or level of traffic stress says this is a good bicycling environment, the best you can do, nearly half or more of the respondents are not saying they would be comfortable in those environments. So that suggests that all of these metrics are saturating far too low to really address the need for bicycling. So we suggest this means that these metrics and any future metrics need to kind of go beyond the top class of these in terms of providing on-road facilities for people. Okay, so after we conducted all these bivariate statistics, we moved into multivariable analyses. And we settled on multi-level models that accounted for the fact that each participant viewed 5 videos. So there's what we call a varying effect for that person. And then we also wanted to account for the fact that there were 25 videos that got lots of different responses. So we have a varying effect for video as well. And what we did was we started with null models. So if you look in the top of that table, we call that the null person model. There are no predictor variables. That model only has a person level average estimated and then a standard deviation for all the people, so a spread based on persons. And then we got, as we go down in that table, we made the models more and more complicated and started adding in variables in chunks. So the next model would be the null person video model. So that includes varying effects for person and video. Then we added the main effects person model, which drops the video effects and just adds person level variables like the socio-demographics, attitudes, and perceptions that I presented earlier. Then the main effects person video, which adds again the video random effect, and then added the video level variables, which is street parking, operating space, some of those that I presented earlier. And then finally, the last 2 models are interaction models, where we considered road level interactions that we thought might be important. So for example, operating space for the bicyclist times the speed limit of the road. And if you look at the right, what we're plotting is the expected error of the model. So how well the model is expected to predict. And the error goes down as you go from left to right. That is, when we're increasing the model complexity, adding more variables, we're reducing the expected error or increasing the performance of the model. There's a big jump as soon as we include the video the varying effects by video, right? So null person is way down near 26,000, negative 26,000, and then it jumps all the way to negative 23,000. So that's where we see the biggest improvement, just allowing the model to understand that there's 25 videos and they have varying effects. And then as we add variables, we kind of see steady increasing predictive ability up until about the main effects person video model. And so the last 2, the interaction models, don't seem to improve the predictability of the models. And so even though we really wanted to include interactions, because they weren't improving the models, and because for the policy analysis was a lot easier to do with the main effects model, we decided to ignore the interaction models for now and report the results on the main effects person video model. Okay, so even though that's what we're going to report, I did want to show one interaction model, because this is where hopefully we'll be moving further with the data analysis. So even though we've just wrapped up this project, the data is now published and anybody can go out there and use it, and we're going to use it to pursue some future publications that dig a little deeper. So this is the first way that we're digging a little deeper, is we considered how gender might vary, the effect of gender might vary on different road characteristics. So on the x-axis is the model parameter, and in the positive side would mean it has a positive effect on comfort response, and on the negative side, a negative effect. And then the little curves, these kernel densities, describe the uncertainty of the effect. And you can see that on the y-axis are all the road environment variables that we included in the model. And what's surprising about this is that although we know there's a big effect of gender on comfort rating, which I'll show in the next slide, when we look to see if there's a moderating effect of gender on these different road attributes, we don't seem to find it. And that is that men and women, the effect of bike lane is pretty similar for men and women, and same with bike lanes with buffer and most of these other characteristics. So this was again another indication for us to stick with the main effects model for explaining kind of how these road environments influence people. But there's, again, like I said, a lot more to be done with person-level interactions. Okay, getting to the meat of the analysis. There are a lot of variables in our final model chosen, so I'm going to step through them in chunks. So again, this is the same plots where on the x-axis are the model parameter values, and on the y-axis are the different variables, and each curve represents the expected effect and its uncertainty. So first we look at some sociodemographics, and we confirm that that women in general are still rating videos as less comfortable, households with children as well, and also older participants are rating videos as less comfortable. When we get into attitudes, we see that the bike-focused attitudes, like I like riding a bike, has a positive effect on comfort. But then other, non-bike focused attitudes, like I need a car for the activities I need to do, has a slightly negative effect. And these tend to kind of correspond with prior research that showed these attitude statements correlate with bicycling behavior. So I like riding a bike tends to strongly correlate with people's decision to ride a bike, but it's also now very clearly associated with people's comfort. When you get to the bottom, close to the bottom of this box, you see that confidence level, willing to ride on a 4-lane road without a bike lane, or comfortable riding on the 4-lane road without a bike lane. These have a really strong effect on how you rate those videos. This is to be expected, right? But this just takes into account some kind of basic underlying attitudinal predispositions, and then conditions on those, and then lets us describe what's of most importance, which is the right side of the screen. Now, the right side of the screen, as you'll notice, has a lot wider uncertainty on all the variables, and that's because there's not near as much variation, because we only have 25 videos in the video, and we had close to 3,000 participants on the person level variables. So that's why these little graphics, these kernel densities are spread so far. If we look at street parking and outside lane width, and even the volume variables, the vehicle volume, they're pretty uncertain, but that while street parking is spread around 0, it's spread quite far into the negative and positive. So we can't, from this data, we can't really say conclusively which direction of effect street parking has, but it certainly doesn't have 0 effect. We just don't know which direction it's occurring. For those others, it's clear that it's likely to have a negative effect. So outside lane width of the vehicle lane makes it less comfortable for bicyclists. but there's a lot of uncertainty in how much of effect that is. And then the low and high volume, those are in comparison to 0 cars passing in the video or no volume. And they both seemingly have a negative effect on comfort ratings. Bike operating space has maybe a slightly positive effect, but again, the model is really uncertain about the effect. If we look at speed limits, the 30 and 35 mile an hour in comparison to 25 mile an hour looks pretty similar. But again, a lot of uncertainty. When you get to 40 and 45 mile an hour and 50 mile an hour posted speed limits, those are definitely reducing people's comfort ratings. And then when you pair that with the prevailing minus the posted speed, so that's the prevailing car speed, subtract whatever posted speed of the video they were viewing, you see that that has a strong negative effect. And then getting into the bike infrastructure, the 2 bike infrastructures we had were bike lanes and buffered bike lanes, and both of those have clear positive effects on comfort ratings. The buffered bike lane nearly twice the effect of the bike lane. All right, so these are kind of the general effects from each of these variables, but it's not clear, partly because these are regression coefficients on a weird scale, the log cumulative odds, because this is an ordered logit model. It's really hard to interpret the magnitude of some of these variables. And so what we thought we would do was we would use the model to make it a little more direct effect and something that's easier to interpret for planning. So what we did was we simulated roads. We simulated our 3 arterials, a poor, an average, and a good arterial, and the same for the collector. And we set the road variables kind of at extreme values within the scope of the data we collected. So for example, for the poor arterial, we set the vehicle volume to high, the speed limit to this high speed limit of 40, 45, or 50. The prevailing speed would be 5 miles an hour over that speed limit, with no bike lane, on-street parking, a wide outside lane of 13 feet, and no bike operating space because there's no bike lane. And then on the other side of that, the other end of the arterial would be good to the extent that we're able to represent a good arterial, and that is still high vehicle volume, but speed limit's much lower at 30, 35, and importantly, a prevailing car speed of 10 miles an hour less than the posted speed, a buffered bike lane, a narrow outside lane of only 9 feet, and then a lot of bike operating space. So that 11 feet includes the buffer and the shoulder. And then we did a similar case for the collector. So that's what we fixed the road variables at. And then what we did is we chose a really, what I'm calling a conservative cohort from our sample. And this is again, to try to find an infrastructure minimum that could perhaps represent a good environment for a lot of people. And so what we did was we simulated 57-year-old women without children in the household who are non-bike commuters, who are not very comfortable bicycling, and in the 10th percentile for bike positive attitudes and 90th percentile for car focused or professional lifestyle attitudes. So this is specifically a cohort that's not predisposed to feeling comfortable riding a bike. And that's the purpose. It's kind of a starting low bar for planning purposes. And here are the results. So we presented them in this matrix. So in the columns are the arterial and the collector, and then on the rows, the top panel are the poor environments, the middle, the average, and the best or the good on the bottom. And then we've also presented the results on the y-axis on the left in 3 different ways, as the predicted proportion of those that would respond very comfortable, those that would respond at least moderately comfortable. So we'd combine the responses from moderately comfortable and very comfortable, and then combining all 3 comfortable side responses. So at least slightly comfortable, moderately, and very comfortable. And what you can see in the first row panel, the top row panel, is that on both the arterial and the collector, it doesn't matter what you do. If the environment's poor, you're not going to get more than 5% of this conservative cohort responding that they'd feel comfortable riding the bike there. When you move to kind of the more average scenario, again, you see very few people, less than 5%, saying that they'd be very comfortable bicycling there. And even at least slightly comfortable is something like 15% for the arterial and 20% for the collector. So still not a lot of this conservative cohort. And it's not until you get to the bottom, the best scenario, where you see, a much larger increase in the predicted proportions of being comfortable. So still very comfortable, not a lot of people in this conservative cohort, less than 20% for that arterial, on not quite 30% for the collector, but at least slightly comfortable, we see a lot more. So half of the people for the arterial and more than 60% for the collector. So what this all in general seems to show is that when you have kind of a population that's predisposed to not be comfortable bicycling, it takes a lot, right? It takes the best environment, and that's just the best at what we have within our data, to even show reasonable numbers of those people that would even feel comfortable, which is perhaps a first step to getting them to consider riding a bike. Okay, so just kind of to take a step back and what all this means in terms of vehicle speeds, it's clear that for the videos that we used and for the population we had, that posted speeds at 40 miles an hour and above had a strong reduction in comfort. And that the difference between 25, 30, and 35 was less certain, but perhaps still suggestive that 25 mile an hour speed improved comfort. And then importantly, when the speed limit effects are paired with prevailing vehicle speeds, at or lower those speeds, that's where we see the biggest gain for comfort. So this, of course, speaks to the engineering and design of the roads and as being a really important part of making it a comfortable environment, not just reducing the speed limit. In terms of bike lanes, both bike lanes and buffered bike lanes have a strong positive effect. Buffered bike lanes nearly twice the effect on comfort. But also noting that adding a bike lane to high-speed roads is not likely to help near as much as adding them to low-speed roads. So if we summed the effect of a high posted speed with high prevailing speed roads, its equivalent negative effect is the same as a bike lane, right? So really the benefit for putting bike lanes in terms of providing comfort is on lower speed roads. In terms of protected lanes and off-street paths, we really can't say anything about those with this data. However, the lack of comfort in our best scenarios when we used our model to predict those kind of best in arterial and collectors from our data, suggested that for people that are predisposed to not feel very comfortable bicycling, off-street facilities may be needed, or even better on-street facilities than what we could provide within the frame of our data. And of course, this suggests we need some future research. We need to now include videos of protected lanes and off-street paths. We need to consider ways of representing bike boulevards, which we weren't able to do. And it's not really clear that a quick 10-second video could really communicate the feeling of a bike boulevard, but we need some thought into how to do that in the future. In terms of sociodemographics and attitudes, we see general agreement across sociodemographics, at least within our sample, and that the road attributes have kind of similar influence in terms of the moderating effects seem to be next to nothing. So that means that, or that suggests that it might not be necessary to provide infrastructure needs by population segment. And what's most fascinating about this is the prior study by UC Berkeley using these same videos with a slightly different question in their survey. They had a convenience sample of bicyclists in and around the Bay Area, and they came to very different conclusions because of the population they had. They saw some real large differences in responses from, say, a recreational bicycling population compared to a non-recreational bicycling population. So this is just to show that when you have a different sample, you can reach very different results. So we still think that the Davis population is a unique population to study because of the experience that they have. But it's not, we shouldn't just conclude that we don't need different facilities by subpopulations. It's just we're not seeing that within our data. And we think that the idea of a minimum infrastructure for a conservative cohort that can satisfy the needs of all might be a good starting place rather than trying to segment the population and provide different infrastructures for different segments. But again, this points to, again, future research to really reach out and get a much broader base of sociodemographics across the state. And I know that there are some ideas on how to pursue that in the future that UC Berkeley is working on. Okay, with that, I'll end here and we'll start the question and answer.
Great, thanks, Dillon. Appreciate that presentation, plenty of food for thought. So we're going to take the last little bit of our webinar here to take questions from participants. Just a reminder, there's a Q&A icon on the bottom of your webinar platform. You can type in your question. And I also want to mention that one of the other study authors, Jane Carlin, formerly of the UC Davis Data Lab, is also on the line to assist with questions as well. So our first question, Dillon, is regarding, I think, trying to determine whether there's a vehicle volume threshold to help determine whether kind of shared use versus now you need a bike lane for a given road. In the videos that your subjects watched, did you have like an hourly or daily vehicle volume for those roads? And if so, did you have any conclusions about any kind of a threshold there?
Yeah, it's a good question. And unfortunately, the answer is no. So the only vehicle volume data we had were the number of vehicles that were passing during the video clip. So it's a really coarse measure for vehicle volume. If there weren't any cars moving in the video clip, we said none. If there were 2 or fewer cars passing, then we said it was low, and then anything above 2, we said high. So yeah, ideally we need to, in the future, find road environments that have well-measured ADT that we can kind of examine. But in this case, unfortunately, we don't have that.
Okay. Couple clarification questions. One, could you maybe just describe how you defined arterial versus collector roads?
We looked at the various videos that were recorded, and we just loosely grouped them based on the number of lanes and the number of cars. The grouping doesn't really matter so much. It mattered in the experimental setup, which I didn't talk about because of time constraints. But we initially designed the experiment in 2 groups, a group that saw videos within an infrastructure class. So if participant A got assigned into group 1 and they saw only 5 videos on a shared arterial, let's say. And then participant 2 got in the between infrastructure class group, and they would see 5 videos each from a distinct infrastructure class. And we hypothesized that participants might vary their response based on prior videos they saw during the experiment. But we found very little effect of that. That didn't really matter what other videos you saw. The survey ratings were pretty consistent. And so we just pooled all the data into one experiment and into one analysis. So even though I described the videos as falling into these infrastructure classes, in the modeling and in the analysis, we ignore the infrastructure class. What we're looking at are the specific features of the road.
Okay, thanks. Another question. So the questions asked of the respondents was specifically about the comfort level of biking on a road rather than, would you bike on this road? Can you talk a little bit about kind of the how the perception of comfort might translate to kind of actual willingness to bike on the road?
Yeah, that's a good question. And I think the prior study at UC Berkeley used a bit more of a behavioral question about willingness to ride. We chose the kind of further upstream question of comfort because we wanted it to be relevant for people that either have already decided or already currently think that they're not willing to bike. And so this gets a little bit at understanding the needs of prospective bicyclists. So when you ask the question, would you be willing to ride in this environment, and you show them a video, well, that already assumes they're willing to ride a bike. And so we tried to get kind of before you even are willing, we just want to know if you'd be comfortable. And so we think that is a good starting point for planning, basically providing a space where people can feel comfortable is probably a necessary thing before they're even willing. So that's how we see it. But we certainly don't know enough to know whether X% of people are comfortable with this environment, and therefore X sub% of that would be actually willing, and then X sub% of that would be actually bicycling. We just don't know that yet. But it's a good idea for future research to figure out these proportions of comfortable, willing, and then eventual bicycling.
Great, thanks. So another question that just came in. So in terms of just kind of overall takeaways, was the finding pretty conclusive that people are more comfortable when there's a buffer between bike lanes and motor vehicles?
Yeah. So in our videos, we had 5 videos that had buffers, and I encourage everyone to go download the data, and it has all the URLs to the videos that I've got posted to go watch them, because some of the buffered bike lanes are next to, fairly high volume, fast speeding cars. But what was clear is that the buffers seem to matter. And it's not clear that if you put a buffer anywhere, it's going to matter, right? Because we have 5 environments that we're showing. But in comparison to the other videos that we showed, the buffers really mattered, and more so, nearly double the effect compared to a conventional bike lane. And that also is included in this operational space that a bicyclist has. So we debated about how to handle that, and a lot of times the shoulder was so wide that we added that to the operational space for the bicyclist, and again, that showed to have a positive effect. So I think just in general, more separation is what people are seeing in those videos, and that's perhaps why they're rating them being more comfortable.
Great. So there's a question about you kind of keyed in on like the physical infrastructure present on these roads, like whether there's a bike lane, separation from vehicles. Was anything about the kind of the environment of the roads, and the example given in this question is whether adequate lighting at night or things like that, were any of those types of factors considered?
No, unfortunately, we don't have any data on that for these videos, and because we didn't present any scenarios to the participants, we just wanted them to use the video stimuli to create the vision for the person. So it's certainly possible that a respondent could have thought about what it would be like at night to ride, but we don't think that that's the natural thing to do. We think the natural thing to do is to observe the video in the present state at which they're, in daylight, good weather, these kinds of things, and respond accordingly. So, but it's a good idea for future. It's a whole nother type of study, but to show the same environment in different settings and to see how much variation in comfort would occur between those settings.
Sure. Okay. So we had a couple other questions come in, kind of exploring this, the connection between perceived comfort or safety versus actual use. And one of the questions was, and I know you said that these videos were originally produced from another study, but the question is whether you have any actual data on ridership on these roads that can potentially be compared to your respondents' perceptions of comfort.
It's a good question. We don't at UC Davis. It's possible that UC Berkeley may have ridership data, although we'd have to look back, because the original study was done on these designated California state highways, and I don't think it was a flag to make sure they were studying roads that they had bike counts on. But it's possible they've done bike counts on those facilities, but they probably haven't done bike counts on the specific leg of the facility that we have video for, which we know bike counts can vary a lot by the actual location at which it occurs. So my best guess would be no, we don't know how many bicyclists are biking on these facilities.
Okay. So another question that is probably a bit outside the scope of your research, but we'll take this opportunity to pick your brain anyway. So a question about parents' decisions on whether to allow their kids to ride their bikes to school, and you talked a lot about how before you even have a willingness to bike ride, you have to feel comfortable. And so, do you think that what you've looked at here in terms of people's comfort level with a given road would be applicable to, say, a parent who doesn't ride their bike, that they drive everywhere, and they're trying to make a decision about whether to allow their kid to ride their bike? I mean, would these types of results say anything about that scenario?
I think loosely, yes. I think that people's responses for what they would think is comfortable certainly isn't going to align with what they're willing to let their kid ride on, but in a general sense, it probably would relate. There are other studies that specifically ask parents about their willingness to let their children ride on certain environments. So those ones are obviously more geared towards that question. And I know there are studies that specifically also look at environments that are, according to current planning metrics, would be suitable, and there's perhaps not surprisingly, a lot of parents say, no way, I would never let my kid ride on that. So I think that's the best way to understand biking to school, is to ask parents directly about willingness to let their kid ride. But in general, I think understanding individual level comfort is probably at least correlated with that.
Great.
One thing, Dylan, didn't we have a variable that reflected if the respondent had a child at home, like an under 18-year-old child, but it didn't actually have an effect in the models?
Yeah, that's right. Thanks, Jane. We had a variable that said whether there was a kid in the household, but we never asked, and it didn't have much of an effect, but we never asked in the survey whether about their willingness to let their kids ride, which is what I was getting at.
Totally.
Maybe fodder for future study.
Yeah.
So we also got a question. When you opened your presentation, you talked about this debate in planning circles versus should we build a lot of kind of low cost investments, like slapping on bike lanes on busy roads, versus kind of investing in more expensive but higher quality and fewer types of infrastructure. Now that you've gone through your presentation, what can we take away from your results to inform that debate?
It's a really good question. I think that I don't know if I have a good answer. I think that it's clear that like putting a bike lane on a busy road, at least in the participants that we recruited, it's not going to help much. And so it seems a bit like a waste to invest in something like that. Now, if that bike lane on a busy road corresponds with lane narrowing and other engineering designs that are going to slow cars down, then maybe that's money well spent. But but just the easy fix, or like what was going on for, 10 years ago when cities started just painting sharrows everywhere. I know there's some studies that looked at, well, maybe that changed micro level behaviors a little bit, but it's clear that we need, I mean, even this isn't just from this study, but it's clear from plenty of other studies that what we need is separation and protection, right? And when you can't have that, it seems like what you need are kind of extremes, where you need to provide a lot of space for the bicyclist, and you need to slow cars down. So I think our study points to the continued movement of more dramatic changes when you're providing on-road features, not subtle little changes that aren't going to really have a big effect on people's comfort. Great. All right, well, we're just about at our hour here, so we're going to conclude our webinar. Dillon, I wanted to really thank you for the great presentation, and wanted to thank all of our participants for joining in today. Please look for a follow-up email from us. It contains a quick survey. It'd be great to get your thoughts on this presentation and topics you'd be interested in learning more about for our future webinars. And with that, you're free to go about the rest of your day, and thanks for joining us. Take care. Thank you.